Hello everyone, this is Amika Mahajan. Welcome to my channel. In this video, I'm going to discuss significance of Coulomb law in position vector form and what are the characteristics of electrostatic force. To understand significance of Coulomb law in position vector form, let's come to this diagram. A and B are 2 points represented by position vectors R1 and R2, where charges Q1 and Q2 are present. So already in last video, we have done force on 1 due to charge Q2 will be 1 by 4 pi epsilon naught, magnitude of Q1, magnitude of Q2 divided by, now final point is A, force is acting on Q1. So final point is A, so position vector is R1. So final position vector minus initial position vector bar Q in denominator, then in numerator it will be R1 minus R2 vector, already done. Now if I want to find force on 2 due to 1, now final point will be B point represented by which position vector R2. Now I will write R2 minus R1 bar Q, magnitude of Q1 and Q2. Then in denominator also I get R2 minus R1 vector. Now check, R1 minus R2 means you are going to point A. So BA is opposite to AB. So when I replace R1 minus R2 by R2 minus R1 or R2 minus R1 by R1 minus R2, I have to put negative sign here. Both are negative vectors. So F21 can be written as 1 by 4 pi epsilon naught Q1 Q2 bar upon R1 minus R2. I am replacing R1 by R2 and R2 by R1. In denominator, there is no effect. Why it is so? Because it is absolute value. Whether I take R1 minus R2 absolute value or R2 minus R1 absolute value, the result will be same as that of R1 minus R2 absolute value. But in numerator, when I replace R2 by R1 and R1 by R2, then what I have to take? I have to take negative sign common. Only then this can be written because these two vectors are equal and opposite. It is vector form, so I have to put negative sign here. When I compare this with this, what I find? F21 is negative of F12. That means force on charge Q1 due to Q2 will be equal and opposite to force on charge Q2 due to Q1. So it obeys Newton's third law of motion. Basically, electrostatic force from this figure, it is clear that is not acting along OA or OB. Rather, it is acting along line joining A and B where charges Q1 and Q2 are present. So such force is a center force which acts along line joining center of two charges. So electrostatic force is acting along line joining center of two charges. So it is central force and it is also conservative force. What do you mean by conservative force? Force is said to be conservative if work done by that force is independent of path, but it depends only upon initial and final positions. Now check here. If movement is along AB or it is along AB like this, then what happens? The force will remain same, whether we move by this curved path or we move by this curved path. That means it is conservative in nature. So electrostatic force is conservative. It depends only upon position of initial and final points. Also, the force is said to be conservative if work done along a closed path is zero. Check here. First, we move from A to B, then back to A. So it is a closed path. We are coming back to the same position, A. After moving from A to B like this, then B to A like this. So work done along a closed path is zero in case of electrostatic force. So this is again proving that it is central force. Also, another characteristic of force is that it obeys inverse square law. What do you mean by inverse square law? That force is inversely proportional to square of distance. This is Coulomb law, which is giving Coulombic interaction between 2 point charges at rest. So what we find that here also F is inversely proportional to square of distance between 2 point charges at rest. So it obeys inverse square law. And electrostatic force is affected by nature of the medium surrounding charges. If charges are in air or vacuum, result will be different. If same charges are at same distance apart, but in water, the force between those two charges will be different. So basically, this force is affected by the medium, nature of medium surrounding the charges. Now, electrostatic force may be attractive or repulsive. It depends upon nature of charges. If two charges are like charges, then it will be repulsive in nature. If two charges are unlike charges, then force will be attractive in nature. So already we have proved that Coulomb law is obeying Newton's third law of motion. This is another characteristic of electrostatic force. Thanks for watching this video. Like, share, subscribe my channel.